Physics Paper 2 is on Friday and it's going to be one of your last exams, so you're going to be feeling extra tired. But don't lose marks by making these mistakes. So the first one for Paper 2 is about motion graphs, and it's all about reading the axes correctly. So for example, if I've got a distance time graph like this and I'm describing this shape, the flat horizontal section would be stationary and the initial one would be a constant speed. However, if it's a velocity time graph, the labels totally change. Station would be incorrect. It would be a constant velocity for the horizontal bit and it'd be accelerating initially. So make sure you read the axes. If it's a velocity time graph, it is going to be a different description of the journey to if it's a distance time graph. So circle the axes when you get to the question and read them carefully. Next thing we're going to talk about is related to motion, and this is about reaction time and stopping distance. Now, stopping distance is one of those topics generally people like to revise. They revise well. However, if you're ever asked to explain why, for example, thinking distance would increase, let's say, for example, with addition of alcohol, don't make this mistake. I've seen it a lot of times. Don't say that someone's reaction time slows down. That is incorrect to say. If you talk about something slowing down, you are only talking about speed or the car's speed, for example. You're not talking about someone's reaction time. What you should say is actually simpler, is that the reaction time essentially increases or takes longer. Okay, it doesn't slow down because we're not talking about speed of something. It just gets longer. Now, while we're here, then distance is proportional to time. So longer time means longer distance. Okay, next thing we're going to talk about is what you should say when mentioning weight and mass. So please don't get those two things mixed up. If you mean mass, say mass, don't say weight. Okay, so as a recap, weight is a force, so measured in newtons, a force produced on an object due to gravity or produced by gravity, whereas mass, on the other hand, is the amount of matter or the amount of stuff in an object. Okay, so mass is therefore measured in kilograms, weight is measured in newtons. So don't forget to not to get those confused. Okay, so how do you avoid it? Reread your answers if it's a written answer, and definitely kind of make sure to use mass in calculations rather than weight. Okay, next thing we're going to talk about is going to be to do with our forces. So we've got a rocket here, for example. It could be a car, could be a bike, could be whatever. If I've got forces acting on it, don't say that forces are equal, even if the arrows look like they're equal in length. Okay, now this might not always be incorrect, but imagine you had a couple of arrows down that therefore add up to make the up arrow. A better way of saying it is saying they're balanced or they're in equilibrium. Okay, and the absolute favourite of mark schemes is to say that instead of those two, say there is no resultant force, or resultant force is zero. It means the same thing, but equal you'll not find on mark schemes, okay, but you'll find those other ways of phrasing the same thing. Next thing we're going to talk about is waves. So moving to the waves topic. Now we've got a wave here, and don't be caught out by saying this value here, this measurement is the amplitude. Amplitude is not the top to the bottom of the wave. Amplitude is the top to the middle of the wave. Okay, so instead of saying especially if you're asked to define it with words, don't say it's half the total height or something like that. What you'd say is that it's the distance from the peak to the equilibrium point. Okay, so that's the point of the wave where it's in the middle, basically. Okay, better way of describing it. While we're on the topic of waves, there's a really good example of making sure you memorize definitions properly and don't wing it or don't blag definitions. Okay, so revise it word perfectly, put it on a flashcard, memorize it, write it out 100 times until it gets in your brain. So the classic example of this is to talk about transverse waves. Okay, so I'll give you an example of a bad answer, an answer that won't get you full marks, and that answer might be something like the wave goes perpendicular to the oscillations. Okay, now they might have the right idea, but it doesn't get you marks, especially with a question like this. Could be 2 marks. So learn key definitions word perfectly off by heart as much as you can. Okay, don't just rely on winging it from memory. Okay, so actually commit it to memory word perfectly. So in this example, what you'd say is that the oscillations are perpendicular to the direction of energy transfer of the wave. Okay, if you want more details on that, do have a look at my waves video, but that's a 2 marker. You need to mention those 2 things absolutely word perfectly. You can't just blag a definition like that. Okay, next thing we're going to talk about is what to do when you get longer answer forces or motion questions. Okay, and if you've done enough past papers and past paper questions, you notice similar things do come up in most years. And what you should try and do is look for hints in the question to help you. So the classic example is a question that might contain the words like explain why something reaches a constant speed or why it doesn't accelerate. All those questions are getting you to try and think about is the answer about terminal velocity. Now you should know about terminal velocity. If you don't, look at my motion video, I'll have a word perfect answer in there, and practice those answers, and don't just try and blag it, but look for clues. If it says constant speed, that's another way of saying terminal velocities. That's what the question's asking you to talk about. Okay, another thing not to talk about, which is to talk about the wrong type of star. Now, this applies to any separate science only. When you're talking about the space topic, when you're doing a 6 marker, you need to read the question carefully because the life cycle of a star can be different or is different depending on its mass. So just to recap the flowchart briefly, stars start off as a nebula or dust or gas cloud, then they go into protostar, then main sequence. I'm running over this quickly. If you want full details, look at my video on it. But the different paths happen because our sun will then take a red giant path into a white dwarf, then a black dwarf. But if it has a higher mass, a much higher mass than our sun, or it's very much larger, it's going to go down the red supergiant, supernova, and then black hole or neutron star. If there's a 6 marker about a question like that and you do the wrong path, you aren't going to get any marks. So make sure you read the question carefully. You cannot stress that enough how important that is. Okay, now last thing, this is just a general thing, is what to trust when you're revising. You've got a couple of days to revise. I wouldn't trust a textbook or revision guide or even YouTube videos, including my own, above these things. So the specification. So make sure you know the specification inside out. What could they ask you about? And exam questions and mark schemes from the recent last few years. Okay, trust them more than me and you'll be absolutely fine on Friday.